Okay. Hello, everybody. I'm Khem. I work for Comcast, and I'm working on the RDK framework, which is their set-top box operating system. Today, I'm going to talk about an alternative compiler called Clang, and we will cover through what we can do with it as far as embedded Linux is concerned, and what are the missing pieces and what are challenges. And of course, we'd like to see that we can go home and replicate and be able to use Clang to do your embedded Linux work. So this is the rough agenda. I don't know if you are familiar with the compiler so far, but we'll give some introduction to the Clang compiler and what its goals are, and then how it is used to compile embedded Linux applications. And then we'll cover how it can be used as a system compiler, and how it can build distributions, how it can fit in, and then SDKs, how we can get SDKs out of it that you can use your cross compilers, which are basically Clang based. And then there's a cool thing about Clang, which has a lot of tooling. It's a very strong point. And we'll cover some of those tools and the value they add to your day-to-day activities. And there's the next step about Clang provides runtime, the C runtime. So essentially, it can work with the existing runtime that you have on the system, and then it also has alternative runtime. So you can essentially replace your C runtime that is on your system using Clang's runtime libraries. So we'll talk about those and how to do. So meanwhile, if you have any questions, just feel free to discuss. It's open-ended. There are many things which don't work, so just we'll go over that and challenges we have. So what is Clang? It is a native compiler front-end to LLVM infrastructure. So I think if you are familiar with LLVM, it's providing infrastructure for doing not only compilers like static compilers, but even dynamic compilers, JITs. And it's being used in several projects. So Clang is just a static compiler, which is for C, C++, and Objective-C, as well as Objective-C++ front ends. And the way LLVM is written, it's written in form of libraries, so you can utilize the libraries, write your own tools. And similarly, Clang has followed the same philosophy, and we'll see how it is utilized in following slides as well. So it was first released in 2003, and as of March 2016, the latest release is 3.8.0, and we will see throughout here. I'll show some of the demos as well. And it's pronounced as Clang, not C-Lang. So many times people, they say C-Lang. It's actually Clang developers, they don't like that, so usually it is called Clang. So it's not about who is better. So I'm not comparing GCC or trying to do that match of compilers here. What I'm going to talk about is how Clang can be used to develop embedded Linux. So essentially, if you're here for a showdown, then I'm sorry to let you down. But maybe in future we'll have more talks about where we can compare some of the code generations and areas where it does better. If you follow Phronix, they do tests. They publish their benchmarks natively, of course, on x86. And if you're interested in some of the benchmarks, how it is doing, then you can look at phronix.com and they have the reports every time either Clang releases or GCC releases. They'll always publish the results of various benchmarks that they have. And you can also go back to many releases, and you can see how the progress has been going on, and how the compiler is doing in terms of its new optimizations and better code generation. So, missing in Clang. Clang doesn't target everything that's out there in the embedded Linux world. So it may not be appropriate for an architecture that you might be using. Primarily, even the front ends, if you are not programming in C, C++, it doesn't have front ends for all other languages that GCC may provide you, especially Ada, Fortran, and Golang. There's a port going on for Golang. It's not complete yet, but maybe in future it will be soon available. So if you are doing programming in Go, you can still have hopes to use Clang. Targets. So these targets that are listed here are some of the ones which are not supported directly by Clang, but if you see at GCC backend web page, then there are many more that GCC supports, and you won't find that in Clang. But if you're using more modern like ARM, x86, MIPS, PowerPC, some of the common newer architectures in those processor architectures, then Clang is definitely something interesting at that point. Features. So it's a new code base. The compiler is written very new, so it doesn't come with the baggage and design issues that old compiler might have. And they had the luxury of redesigning the pieces in certain way that you couldn't have, for example, with GCC. For example, even if you wanted to redesign it, it's an incremental approach. But LLVM and Clang community went with more API-based architecture, which means everything they were exposing as libraries. So in compilation, you have abstract syntax trees, and so they interact at that level, which means, and they provide you hooks into the tools which are generating those, so you can easily write your own tool and get the information that compiler would otherwise see. And you can write really good tools, not only the compilers, but your own tools that would support you to do what you are doing. So it's a very strong feature. There are certain tools, we'll go through those in the end, that those are a single C file, and it achieves so much, like syntax checking, and so they're very powerful because all they're doing is they're hooking themselves into the Clang libraries and getting all the information that's available to you, so you can do really a good job. And another focus that the project had was that it should be fast, which means fast in compiling your code, and it lives up to that hope still. It's getting complex, but it still tries to focus on being a very quick compiler, and you can see generally on large C++ code, actually it performs really well as compared to GCC in terms of compiling speed. And user-friendly diagnostics is, I think, a well-known feature and a strong point for Clang in general. It pinpoints the errors really nicely, and it gives you diagnostics which are humanly understandable. Especially when you are doing a lot of templates and C++, then you would see that the diagnostics you're getting from the compiler are sometimes very, very elaborate, and you really don't get the error, but you get a lot of messages that a compiler developer would understand that what compiler is doing, but not a user. A user might be unaware of the fact how compiler internal machinery, parsers, and all are working. So those messages made sense to compiler developers quite a lot, but not so much to the users. More than that, they confuse them to see where the errors were. So it's a very strong point for Clang that it tries to add a lot of diagnostics which are pinpointed at the errors, at the point in your source code where the errors are, and it tries to inform the user what could be wrong and why. So it's very, very good at that. And besides that, diagnostics, it's very accurate on diagnostics as well. So it catches a lot of errors in your existing code. If you just throw your code, Clang at your code, it'll catch more errors. And sometimes the diagnostic levels for warnings, for example, it may treat that as an error, whereas you might have been living by treating that as warning. So it just informs you about the gravity of the problem that you have been ignoring as a warning. So, I'll show later on in my talk that there were issues that we found, and that turned out to be real issues which were being ignored. Moving on to the features and goals. So it aims at GCC compatibility. So it has all GNU extensions which are possible to implement. They are implemented or they are recognized. And in some cases, you will get diagnostic errors that it couldn't do anything about it if it is not implemented. But it will recognize it and at least try to do a best effort information for you. And it intends itself for an IDE integration. A lot of application developers and other platform developers, they are interested in IDE integration. So Clang designs itself to write tools or to have hooks from your IDEs that pokes into the compiler and gets the best information out of it. For example, when you are like looking at one file and you want to see why this diagnostic is happening, you can tell it. You can kind of like select portion of your file and recompile it, for example. So it will invoke another tool underneath which will just quickly recompile that piece of code and try to give you a quick answer. So and then there are more tools that you can integrate basically into IDE. So that's one of the goals that the project has. And it uses the LLVM BSD license, so it's more BSD-like UI/UC license code. All its runtime is dual licensed under MIT and LLVM UI/UC license. And language conformance, it's very particular about being conformant to the standards. So there has been numerous requests to support features that were there already in compilers like GCC, which people have been using, and Clang community has stood very firmly against implementing them in Clang because they are not in C standards. One of those is nested functions, for example. And variable length arrays. It just simply refuses to implement those. So it's a good thing in general, and but yeah, it creates issues when you're porting code over, and you have large code bases where these things are used very often. So you have a lot of issues in there to deal with. But I guess that's a change for good. So I would support to rewrite that code in a better conformant way in C or C++. It's way ahead of other compilers in terms of implementing standards, C++ standards rather. So you would see that it's conformant to C++ 14 and C++ 17. Implementation is also complete in the master version of it. Some portions of the 3.8 is actually fully C14 compliant. Of course, GCC 6, which is going to be released soon, will also be fully compliant, and switching to that as a default standard for C++. What you might have also seen is it's using color coding for diagnostics. I know that some people don't like it, but in some developer community, it is a desired feature. And if you remember, there used to be a project called Color GCC, and it's similarly it was trying to color the GCC output using a Perl script. And Clang took that as a feature to its diagnostic engine. And if you use GCC 5 or newer, then you would see even GCC has this feature now, so it's pretty good. Some of these detected errors, I don't know if you can read them, but these errors were found when I was compiling certain parts of packages. And what it was complaining there was we had a use case of logical and operators. So it was complaining about that. So when we looked at the code, it turned out to be that, yeah, it should be and operator should be replaced. So it turned out to be a real problem, and the patch was submitted and accepted into the XF86 video subsystem. This was not being detected by GCC earlier. Yeah.
Query, will it do that with a constant operand that is 0 or 1? Because something a lot of code that I've worked with does is you have a config symbol that resolves to a constant 0 or constant 1, and you use dead code elimination to make it go away.
Yeah.
So will it still warn about constant 0 or constant 1, or just constants under those?
Yeah, to be true, I haven't faced myself that's a good scenario. I think it should warn about it if it's not optimizing away, because the second thing is the errors are after optimization. So it's going to, if it is being run through DCE, then probably you won't get there in there. But this is a macro expansion at that level. So I think it's basically finding it out before the DCE is being done. And I haven't tried, maybe at a different optimization level it would go away, I'm not sure. Yeah, the other error was in a Raspberry Pi userland package where it was doing a double increment of a index. There is a new option which does a for loop analysis in Clang. So that's something that was going undetected, and there were issues we were seeing, especially when Wayland was in picture. And so this was a good test to run through, and once it fixed, an issue was fixed which was happening, but nobody knew what was going on. So this was an indexing error that was not being caught. So there are many examples of that sort. I just listed 2 of those, but there were a few more that we figured out and that we were not seeing with GCC earlier. So then you looked around who is playing with Clang. So Clang is fairly new entrant, and there is a lot of interest in Linux-based ecosystems already on Clang, and Debian has a port going on, and they have they're experimenting with Clang and trying to compile the whole Debian repos using Clang, and they have approximately more than 90% packages that are now compiling with Clang, so it's got a wide coverage for Clang. LLVM Linux is another project which is intended to get Linux kernels compiled using Clang. So they have done a lot of good work in kernel, and they've upstreamed a lot of patches, into kernel to get it compiled with Clang, and which were generic fixes. However, there still remain certain fixes or certain issues which are not yet upstream, so it's not fully upstream kernel may not be yet compilable with Clang fully. So there are still patches you would find on LLVM Linux project that are that you need to apply in order for you to compile the kernel using Clang. And it may not work for all kind of machines yet, so they've only targeted a subset of machines, BeagleBone and Raspberry Pi and maybe x86 boxes. So not all kind of machines are yet compiling and their kernels. The ELK compiler collection is actually a cross SDK. They built a SDK, using Clang as their primary cross compiler and Muscle as their C library. So they don't use any of the GNU tools essentially to build their tool chains besides bnoodles for linker and assembler. And so you could use that as a if you're familiar with cross tools project, which puts up cross tool chains for GCC based cross tool chains. It's similar in nature, where it puts together Clang based tool chains. Of recently they've been able to build a Raspberry Pi root FS. So but they are carrying a lot of patches as well, kernel being one of those and other patches, but it's a good progress that they've been able to run a full root FS compiled with Clang. FreeBSD has switched to it as their default compiler, and they are progressing with that. They are using other parts of Clang as well in their ecosystem. In terms of Linux distributions, OpenMandriva has switched to Clang as well, and they use a mix of Clang and GCC. And what I'm going to do today is I'm going to basically cover OpenEmbedded and Yocto Project work, that what we are doing here. It's very similar to what they might have done in OpenMandriva as well. So these are a few of the interesting LLVM Clang projects that people are doing around Linux or other projects. So using Clang for embedded Linux, the challenge is essentially because we are cross-compiling. Most of embedded Linux systems are cross-compiled. Whether you use any of the build infrastructures out there, it's mostly cross-compiled. Besides now, there are Fedoras and Debian, which is coming up with native bootstraps, but generally people use cross-compiled tool chains to build their system. So, so it's only not limited to compiler, but you need the whole tool chain to be able to generate code for your architecture in a cross environment. And as Clang itself is actually a cross compiler in the way that it has a driver. They call it universal driver. So universal driver, if you don't pass it any options, it passes the native options, and it makes it behave a native compiler. But inherently, it is a cross compiler. So basically, you will have one compiler which has all the backends. So like what you do, in the GCC, that every backend is different, right? So you have a cross compiler for MIPS, another one for ARM, and so on and so forth. In this case, you have a single compiler which will have all the backends available, and you would configure the universal driver with the right options that will go over, and then you will be able to use that as or it will be able to invoke the right backend from the Clang compiler. So it makes it very simple as far as cross-compiling is concerned. You really don't do anything different. You just build like Clang, how you build, and then you configure, basically invoke the Clang driver with the right kind of options. And, So one of the ways, so this slide I'm talking about how you could just not build it first, but you could just use it. So we just talked about that we have, it's inherently a cross compiler. So you could see this where you can download or you can install Clang on your host Linux distribution, Debian or any of those. Arch, they also have Clang packages. Most of them have nowadays. And then you can download a cross toolchain package. The reason being that we still need the assemblers and linkers, and of course the sysroot if you are linking. So that's why you can just try it out with pre-built stuff. So that's what it is. And you can download any of the pre-built tool chains, install them, and add them to your path. And then you can basically just use the Clang driver that I'm having a command here where you specify your target and then you give it a CCC, GCC name. So cross, yeah.
You said that Clang is a universal driver that can compile for all of its targets.
Yeah.
So these different architectures we download, that's the different hosts it runs.
These are the cross tool chains targeted at different architectures. So it's just to get the binutils basically, fundamentally. Once it has its own LLD and the native assembler available, maybe even that won't be required. But right now you might need that. That is why you will have it. So once you have this, then at that point of time, it is basically you can use Clang to do your cross compiles, as well as native. Yeah.
So it uses the GNU binutils.
In this case, yeah.
Can you choose between LD and Gold?
You can choose between LD and Gold. It has the same option at GCC, which is called fuse, minus LD, and you can specify which linker you want to use. Now, actually, of late, I think this release, the native linker has gotten a good support as well for various enhancements. So that is also an option. So you have 3 linkers essentially that you can use. You can use the one that comes with the LLVM, and then you can use one with that's the BFD linker, and you could use the Gold linker, which are both from GNU Project. So this would only compile the application with Clang, but the rest of the system is still whatever you have. So it's only utilizing the Clang front end at that point, and the code generator, and then code generator is internally invoking GNU binutils to generate the code as well as link your applications. Now you got a cross compiler, so you could basically even use the same thing to build your kernels on your host system. So you basically have stitched together a cross tool chain which uses Clang as a cross compiler for your tool chain. So in this slide, what I'm talking about is to build the whole platform. So there are infrastructures out there like OpenEmbedded, Yocto framework, other distro builders which builds a platform for you. So we have challenges there still that you can't go end to end using Clang yet. The Linux kernel effort we talked about. There is LLVM Linux project. Which is still, which has done a lot of work, but some patches are still pending to be upstreamed. And then system C libraries, for example, glibc being one of the primary libraries that's used in the Linux world, it doesn't yet compile with Clang. So it uses a lot of GNU extensions. There is a project, glibc meets Clang. So if you're interested, porting, helping, just go in there and see there are work items that are listed. the portions of code which needs to be changed for glibc to work with Clang. So there are a steady stream of patches that keep coming sometimes to fix it, but it's still not fully done. Yes, Musil compiles with that. Yes, yeah. Oh, sorry, I should have repeated. Yeah, Rich Falker is actually the author of Musil, so I think it's. Okay, so this is, I'm going to show like how it fits into the toolchain build sequence. So this is a rough diagram of how a toolchain is built, or a cross toolchain is built, or rather a toolchain is bootstrapped. So if you are not working with Fedora or anything, and you're bootstrapping your system, you need a toolchain to bootstrap, especially cross toolchain. So this is a roughly sequence where how you build it, that you have to like do some hoops around, to get a real compiler working. Especially the problems are around how GCC is building itself. It wants everything in the tree when it is building, but so in order to overcome those issues, that's why the sequence looks like this. The Clang build is very simple. You just build the compiler and it doesn't need anything else to build. Here we need to have library headers. We can't build the full library, so you just build the headers. So then you build the cross compiler, then you build the libc again. So there's a lot of dance that we do. But right now, what you can do there is that you can just have the Clang universal driver as well as the Clang cross stub. So what is Clang cross stub? It is actually if you create a symlink to the triplet, then the universal driver understands. So I gave you that long sequence of options. You really don't have to specify that. You just create a symlink to Clang driver with that triplet, and it knows to pass the right options. So it's, yeah. So LLVM provides the code generators for Clang. Clang is just a kind of a front end, a language front end for it. So it's providing you, the C, C++, and Objective-C front ends, and in turn, what it generates for you is a output that is understood by Clang, by LLVM backends, which is then generating the machine information for you, all the machine code and everything. So that's. No, actually what it ends up is a static code. So you can basically generate assembly files out of Clang. So it has a inbuilt kind of assembly generator. So it has many backends that you could do. So the runtime, the LLVM for what it was meant for is a separate backend, which it does like dynamic compilation and everything. But this Clang is for static compilation. In this case, yeah.
You know how GCC has multiple language front ends that produce an abstract syntax tree, and then from the abstract syntax tree there's an optimizer that produces machine language output? Clang is everything before the abstract syntax tree. LLVM is everything after.
Yes, so it's just the language front end, if you will. So right now we have a hybrid approach where we need both GCC as well as Clang available if you want to put together a platform. And Chromium OS has actually a overlay for Clang. So you could use Chromium OS, and then you can do certain packages one way, certain packages another way. OpenEmbedded does exactly the same thing, where we provide actually a layer which provides you the cross compilers as well as the infrastructure to choose which compiler to use, whether you want to use GCC or Clang. For the simple reason that everything we cannot compile with one compiler, so you have to go with this approach. So certain pieces can be compiled with either way. So what is OpenEmbedded's approach? OpenEmbedded's approach is actually we will define a variable that you can put in OpenEmbedded's recipes, which defines which particular tool chain you would like to use to compile this particular system, or sorry, particular package. Right now, how it works is when you plug in Clang layer, then Clang becomes your default compiler. So if you don't specify your toolchain type to it, then he's going to use Clang to compile your application. But if you have an application that is not compilable with Clang, or you would like to use GCC for that, you would set one of these variables in your recipe, and then it will use GCC to compile it. Since we haven't yet made it default in OpenEmbedded core, so maybe these defaults would change if it is in core, where GCC becomes the default and Clang is on optional basis, where you can choose which particular packages you would like to compile with Clang, or we don't know yet if it will be an option, a global option to offer which is the default. We will see. Right now it is only available when you hook in the layer and it becomes default. That also can mean that you cannot use it generically on your system, because suddenly it will start compiling everything with Clang, and not everything would work or may work.
Yeah, that would be my question. So if it's switch it, then I should already have a working system or root file system, so that I only can build additional packages.
Yes.
Because otherwise, I cannot build an kernel, I cannot build GCC.
Yes.
So I could switch to Mutable.
Yes. Right. So what you can do right now is, if you are switching to OE core and just Clang layer, you can build all images actually that are in OE core with the mixture of Clang. And I'll show there are certain packages that Clang layer holds. It knows it can't compile, but it's not a whole list of packages. It's only a very small list of packages that it sees in core layer. But if you add more layers to it, if you add Qt5, you add other layers, then it doesn't know about those. And it will start compiling them. You might have to add it to the exception list.
Can toolchain be conditional on the recipe?
Yes. So this is what you will see here in this, where you set this variable. You can do that in a BB append. And then you can choose which layer, whichever you want. But if you see here, then I hope I have access. But it would have shown you if I have. Anyway, it would have shown you the list of packages that are excluded as of now. So there aren't, from OE core, there are about 22 packages which it can't build as of now. And some of them are like, Linux kernel, glibc, various versions of glibc, and grub and others. So, there are a few packages which don't compile. So there are reasons why these packages aren't compiling, and some of them are using specific GCC extensions. So Clang has an option to enable GCC extensions, and certain extensions it doesn't know about. There is an option called Affinius GNU extensions. You can get by with that, but then there are beyond that which it hasn't yet implemented. So it will error out on those. So you have to find a replacement for that. And in some packages, there is a use of nested functions, which we talked about that Clang community doesn't want to implement. So that has to be redone. And VLAs is another use case. I found, I think, at least 2 or 3 packages which were using VLAs, which is replaceable. So we tried to fix those, and maintainers were accepting the patches, so that went well.
For VLA, isn't that just VLA in structure?
Yes, VLAs in structures, yes. That's not VLAs in general. Yeah, it's only VLAs in structures. Yeah.
And I note that you are allowed to have one VLA at the end of your structure. Just make it link 0 and manage your own memory.
Yeah.
That's different from the extensions, right? Yeah, no.
Right.
The extension is when you put it in the middle of the array.
Right, right. Yeah, and I think the Clang community says to be wary of that, because that's also undefined behavior, what you're talking about. So generally it is something that they stick to the book when it comes to the definitions. And yeah, that should be allowed, but and so there was some discussion around that where they were trying to shuffle the objects. Yeah. So some fixes has been done, but they were not accepted by the communities because either it was working for them and they just said, why are you making my life difficult? In some cases it was thought to be intrusive because it was either changing some core function prototypes or adding few things to functions which they thought would require a lot more testing, so it wasn't accepted. Some of them have been accepted, but in that list, if you see today, go to that list. We haven't yet updated that list because many of the releases are not available in OE yet. We haven't updated those recipes. Some of them have valid diagnostics. We know that they need to be fixed. It's just that nobody has gotten to that. So eventually we might get to fixing them, or somebody else before us in a different thing. But there still are packages that are listed there which are not yet compiling with Clang. So if you were to build the distribution, then this is how you would do it. So I've just used the Yocto reference distribution here called Pocky, but you could also do it with the OpenEmbedded core, doesn't matter. If you are a OE guru, it's any distribution you should be able to use, which is based off of OpenEmbedded. Yeah, so you just add the meta Clang layer to the mix, and that's all. You should be able to then, it will kick in and start building Clang as your default cross compiler. So what can it do today? To answer your question earlier that Rudy was asking, you can build Sato image, you can build a minimal image, and other images too. I don't know all. I haven't tried all images that are available in the OpenEmbedded core, but it can build a basic image for you that you can build on top. And it can also generate SDKs on those images. So you can have a core image minimal, and then you can generate a corresponding SDK for application development. And it's simple. You just utilize another command where it will generate a standalone toolchain for you. And this toolchain will have both GCC as well as Clang available to you to use in your applications when you're developing. And so I've listed here how you could install it. It's fairly straightforward. The SDK that it comes out is a self-installer. It looks like a shell script because it is wrapped around a shell script, but it's essentially containing the whole cross tool chain and the root FS against which you can develop. The using of SDK, you just set up the environment. The script there does set up the environment for you. What we have done is, generally what script will do, it will set you the CC, CXX, and CPP and all those variables. What we have done is we have added more variables to it to be able to use Clang. And one of the reasons to add those is that you could just set CC equal to Clang CC and CC equals to CXX equals to Clang CXX in your make files to make it easy for you to utilize Clang in your make files. And once you set up your environment, so these variables are available, and you can basically utilize any of those compilers. I'm not sure whether I have, I can show you. Yeah.
Do the Clang compilers look at C flags and C includes, or C Clang C flags?
Oh, they look at C flags. They look at C flags, yes. So generally, Clang's diagnostics or the messages, or rather options, are compatible with GCC. So generally, it should work in general. But if you want to use a specific option that is Clang specific, then you might have to do a more additional work. But most of the times, this should work fine. So I have, you can do any examples. I've taken the AutoTool-based application and used the GNU Hello World program. And I have successfully compiled it using the SDK and transferred it to an emulator. And I can just see if my internet is back. No, it is not. Okay. So what you can see there is you can simply use SDK to compile any application. What is important there is that you set your CC to Clang CC like this before your configure, and it will use Clang to compile your application there. And if you want to see whether it is using Clang, you can use make v equals 1, and you can see Clang being called during compilation. And if you are doing kernel work, you can use the same SDK to compile your kernels too. Here, what I've given example is to compile a LLVM Linux kernel, and because they are carrying all the LLVM and Clang patches, you should be able to build it, but then not for all the architectures. I tried to build it for AArch64, and it didn't really compile, but it ended with a legitimate error messages. So if you are compiling your own kernel that you're working on, you could compile using Clang, and if you run into issues, those are real problems. Fix them, and send your patches to LKML or wherever they belong to. And in many cases, we have fixed Clang for issues that were found while compiling kernel. So if you run into an issue that is a Clang issue, I think Clang community is happy to fix those issues in their front ends too. So either way, the fun begins at that point. As I said, kernels are not yet compiling fully. That's an open area for everyone, so I encourage everyone to use these SDKs to start compiling. So far what we have done is we have just used Clang as our compiler, and everything else remained the same, more or less. We use an alternate compiler, but our system C library, our runtime, they still remained what they were. So we can keep going. If you want a break or anything, just let me know, because we still have a few more time to go with this. And if we can keep going if you feel like. Yeah.
Go back 2 slides.
So the 2 topics that we want to talk about is generally what the tools are available around Clang. Now we know how we could use Clang to compile your applications and your kernels. We would talk about tooling, and then we would also talk about the most interesting part in the end, where you can use the Clang runtime to replace existing GCC runtime on embedded Linux, and it works. So Clang has additional tools that you can use, and they are very, very good in terms of providing some additional functionality to you. And static analyzer is one of those. It's called scan build, and it's probably has some value. It's still being developed. Static analyzers are never complete. So when you compare it to some of the solutions that are out there, like Verity or others, it may not be as complete as them. However, it's a start, and it's always developed, and it's getting better and better with every version. So you can integrate that into your workflows, and generally use that as a tool that's available with the tool chain. So here I show you the options where I ran the static analyzer on Missile C library, and so I could run it on native build, and I could run it on cross build. So I just wanted to make sure that I could do it in both cases. So if you are doing a cross build or anything, doesn't matter. And so the results I posted here, and the Missile community jumped on it, and actually they fixed 2 issues based on that. So that was pretty good. So in the end, it resulted in at least a little bit of improvements. However, it does report a lot of false positives. But then I think a C library is not a typical software where it can track everything, because C library does a lot of stuff that a static tool may not be able to understand. So I think that if we ran it through a simple application, it would probably find more cases and less false positives. Yeah.
Do you have any tooling so that people using OpenEmbedded could use the static analysis on all the code, but then use GCC anyway to actually generate the image?
Yeah, as I said, right now it is tooled such that the default becomes Clang, but it is not hard-coded. So you could set a global value of your toolchain still to be GCC. But then it will compile the SDK for you. The scan build tool will be available, but then you have to tool it. So we haven't written a global class of some sort which will do which you can insert, inherit it, and then every package will be scanned. But I think that's an improvement we could always work towards. At work, we have done something like that. Yeah, but for a different tool, not for scan build.
So you're still, at work, you're still using GCC for your final images?
Yes, as of now. But we do use scan build tool, for example, to do our analysis before commit, after commit, and all those. So because it is fast, It doesn't have the, you don't have to set it up like Kubernetes. It's very time consuming. In this case, it's easy to automate. And it doesn't catch everything. However, it gives the value that we are expecting in our workflow.
Do you have it set up with your Gare?
Yes, yes. So there is another tool called Clang check. And Clang check is a syntax checker. As I said before also that you can check the syntax without really compiling the file. And it's quick in that way that it's not going through all the process of compilation, and you can quickly get the results. Helps, ID. And fix-it mode is that if it finds a syntax issue, then it can fix it for you as well. It's a little scary, but I think it's there. It tries to fix it. Anyhow, Clang format, that's another tool. So it's so this is all these tools are very small, but they do a very good job, and they are written using the lib tooling, which is the infrastructure that Clang has for letting you write all those kind of tools. It's not limited there. If you have specific requirements, you can go and write your own tool. And Clang format is to enforce certain coding style, right? Like Linux has its own coding style, and many projects like GNU coding style, and we all use Vim and Emacs, and they have those files which auto format your code. Clang format is something similar, which you can enforce when you're either accepting somebody's code or you can just scan it. So it's a good utility. I remember in some of my previous works where people wrote scripts to achieve the same functionality. Now this can do a lot better job because he has access to the intermediate representation of what compiler is seeing, and so it's very powerful from that point. Yeah, you can add more checks to it. So it is. Yes, it has a config file for that. And I think you can add also, it's not complete by far, not yet, right? So there is a lot of things that it doesn't do yet, but it's starting there. And Clang tidy is a linter tool. Similarly, there are many other tools that people have written that I don't know, that people haven't yet talked about. But I know for sure that people are using libclang quite a lot to do a lot of plugins that want to take advantage of compiler front end or the AST or intermediate representation level. It provides you hooks like before compile, after parse, so you can take actions in your tool, and it provides you the information. It's provides you pointers into the data structures where you can extract all the information and do the action you want. So it's fairly well designed from that aspect that you are really linking to a libclang.so and then getting all that information. So it's pretty good. So very good tool if you want to write your own tools. I've written some tools around before in the past, and so I find this very useful for myself as well. So, but Clang has also now moved over to provide certain extra projects, and libc++, for example, is their C++ runtime implementation. And it's right now being used in FreeBSD, I know for sure, and it essentially provides all the functionality that you would require for C++ runtime. STL is essentially what libc++ provides you, so it comes in combination of certain projects that you can provide the full runtime. The ABI, which is the libsub C++ in GCC's form, for example, is provided by another project called libc++ ABI. And the exception handling support, which is the bottom piece of your C++ runtime stack, is actually provided by a project called LLVM libunwind, which was contributed, I think, a couple of years ago to provide the the unbinding functionality. So what you can see there is there is a command line switch called -std lib. So you can select whether you want GNU std clibc or you want libc++ as your standard STL implementation. And in that example, as I've highlighted, that once you choose stdlib equals libc++, you would see that he would have linked the libc++ shared library into your object. He will use that at runtime. So the other portion that it provides us is the Clang called compiler RT. So compiler RT is a collection of libraries which provides two things. One is the compiler built-ins. So the compiler built-ins are what you find, all the integer promotion and demotion and all those functionality that is very specific, which is implemented in libgcc, for example. So today, compiler in GCC, if you do a conversion like float to long or long to float, or you do these typecasts, then compiler, if it can't do it in a effective manner, then it will basically make a call to a built-in, and it would expect that that built-in is coming from libgcc. So compiler RT provides a portion of library which provides us all those built-ins, the compiler built-ins. The second portion that it provides us is the sanitizers, and the built-ins are actually fully compatible with libgcc interface. So if you have a code, you may be calling those functions for whatever reason, it's still fully interface compatible with libgcc at that point. The sanitizer runtimes are are new, and actually even GCC now has got sanitizers contributed to GCC project as well. But the Clang runtime library provides the necessary support for you to be able to use the sanitizers that are provided again as part of the Clang project. And it also has a profiling library that you can link in for traditional profiling. I haven't used it myself, so I don't know how it works, but it's there. So if you're interested, you can try it out yourself as well. So there's sanitizers that are available. It provides you address sanitizers. So there is an option called fsanitize, and you can specify whichever sanitizer you'd like to use in your code. And then compiler RT will provide you the necessary runtime and that you would link into your application. And it detects memory errors, out of bound access, and all those good stuff. And the compiler instrumentation will be added by the compiler itself, and the runtime would come from a static library, actually, or a shared library from compiler RT. Thread sanitizer is relatively new sanitizer, but it can detect some data races. So if you're having data modification issues, thread sanitizer is a good tool. And memory sanitizer, again, if you have reads that you are doing which are not initialized with right kind of values, and leak sanitizers. It can do some memory leak detection, like what Valgrind or all those tools would do. Data flow sanitizer is fairly new. It's supposed to do some data analysis I don't have details on what it is eventually going to do, what it is aimed at for, but it does exist in the master branch of Clang. So I thought of mentioning it here. But I guess it is, reverse engineering your code and just seeing how the data is being modified, essentially how you do traces in GDB, and so, helping with that basically in that. Clang compiler's runtime provides the lib-unwind, essentially is providing us the unwinding implementation, all the system unwinding that compiler will depend upon, and it implements all the functions that are required by the higher level C++ or C runtime, and as well as the traditional HP compatible APIs called, they will start with the UNW something. So it's a replacement for lib-unwind in a sense, and provides the needed runtime support for other functionality as well in Clang compiled programs. So this is here, I tried here, I think it is really small, but what you can see there is the first program there is just simply compiling a hello CPP with default GCC, with the default Clang, and if you see what it linked in, then you would see it's linking in libstd++, and then also libgcc _s in there. Now, if you specify the options now to say I would like to link with libc++, and I would like to use lunwind, and I would like to use no default libraries. Basically, I would like to kick out libgcc_s from my linker path. Then you would see that he's able to build it, link it, and resolve all the issues, that all the symbols from compiler RT and libc++, and the program would run as well. So you would see that it's linking with libc++, and instead of libgcc, it's linking with lib-unwind to provide the necessary unwinding part of libgcc. So actually, libgccs has two portions to it generally, the unwinding as well as the built-ins. In this case, those are separated out into two libraries. Yeah. Yeah.
What happened to the math library? You don't have to link it.
It was not required, I guess. So I just no.
First one, the second one is libm.
Probably the standard C++ from GCC depends on the math library over there.
Okay.
Where do you see libm? I don't see libm.
The top set, the top second to the top four.
Oh, yeah. So I think, this is the standard call from the standard GCC when you don't specify any library. So it was actually an unnecessary link. Nobody was needing it, yes.
Question. libc++ and libc++ ABI, what's the difference?
So if you remember, in GCC world, there is a ABI, the runtime portion of it, which provides that GCC exception handling, personality routines, and all those. The libsup C++. So that's the supplement portion, which is actually interacting with the STL portion, bringing all the exception handling routines basically interact with STL. So it's a middle layer between your STL and your unwinding routines.
So this is a libg++_s, essentially.
Yes, yeah, portions of it, that's right. But it's the C++ part of it. So in GCC, that is called libsup C++, lib supplement C++. Yeah.
So, as you have lib-unwind there, you have to also enable
Unwinding?
unwind data.
No, you don't have to. Basically, this is, if you have exception handling in your C++ code, then yeah, you gotta have it, yes. So that's why it is linked in there, yeah.
I assume that, that this linker has the dash dash as needed stuff.
Yes, that is default.
There's no like macro you can say to grab all these Clang versions of the libraries instead of the GCC versions of the library.
No, there is nothing like that yet. So the Clang community provided this STDC switch to switch between the C++ runtimes, but not between the C runtime yet, maybe in future. So that such an option doesn't occur, but maybe in future there will be an option where we will just say on the command line, another option which just basically will do exactly what we are doing on command line.
Presumably in some future version they'll change the defaults and leave themselves further off of GCC.
Right, yes. And we just have to cook up a patch for that, essentially. That's where it comes down to. So we still have a few challenges. Essentially, we have certain application packages, not all of them are yet compiling, as we know, and it's only a subset that we have tried. So there may be more. But the Debian project gives hope, right? So 90% of Debian is compiling with Clang, which means there's a lot of packages which are already available, can compile with Clang. And the small list that we carry here is probably interesting for us, but I didn't see that it's a bigger list. I think we have even smaller number by now than what we were there. So, but still there are a number of packages that we need to work on to get them compiling, and I would hopefully prefer this list to be gone, and nothing to be in there, and have it as a
Does the FreeBSD project need GCC for everything?
They do right now. They have it as an option available. Everybody does similar way.
No, I'm wondering, is the FreeBSD kernel and C library?
No.
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 So
Yeah.
they're doing the same thing. They have
Yes.
90-something% instead of 90.
Yeah. I think the difference there is that the default runtime is not using GCC at all in FreeBSD. Right. So there are other projects which are now, like Android is also using Clang, but Android has always had their own runtime. They never had the runtime issue. However, yeah.
Question, in the Clang, the recipe is already in the repo.
Yes.
How hard would it be to backport it to like 1.8? Does it have a lot of dependencies on too low?
So what we did is we renamed certain compilers, names and all. So I don't think the backporting should be more cosmetic than fundamental changes. If it is 1.8, you said, right? So yeah, 1.8, it should be definitely doable, but it's not a drop-in for 1.8. It's a drop-in for 2.0 and forward as of now, but not, yeah. That's what I'm saying. It is now compiling. However, I haven't updated this list. Yes, yes. So this list hasn't been updated. I have to update this list. As I said, so many packages are already now compiling with non-Clang. So this was a approach towards getting a buildable image, and then start working on fixing the packages. So to get to a certain level where we have a bootable image, and then replace packages by packages and not regress. Yeah, and then we have the SDKs now. We need to kind of integrate those into various other toolings that are out there. whether it be to Yocto tools or Eclipse or Kdevelop or all those tools. Upstream kernel doesn't compile with it yet. So unless we have a kernel compiling with it, we cannot claim that we can build a full ecosystem, embedded Linux ecosystem with Clang. So I think that's all I had. So if you have any questions, let's talk about it. Or any questions you have, any comments, we are open. Yes?
I have my original Linux project. I switched the build system down to the smallest, simplest thing I could, got it down to 7 packages, but that's old GCC. It's GCC 421 and been until 217, which is why GCC had metastasized to 5 packages. I have meant to replace that with LLVM for a long time, but whenever I look at building LLVM in a circular way, so I'm also building all the dependencies of it, it has an insane number of dependencies. During your talk, I downloaded the 380 source and ran configure on Clang, and it said, configure is deprecated, you'll need to use CMake soon.
That's right.
Previously, I tried, and it refused to build on any GCC before 4.7, and I think
That's
that
right.
it's moved forward since then because it now requires C++ 2017 features.
Yes.
That hasn't even happened yet.
Yes.
Do the Clang developers just only want to distribute binaries, or do they have some sort of plan for not checking, you're on this specific version of Ubuntu, you're building on a Linux distro we don't know about, so it won't work?
Yeah, I think they bootstrap Clang with Clang. So I think they are not looking, or they are not experiencing or even thinking about the issue that you might be talking about. So there is I think they take Clang to bootstrap Clang, right? So I think they've probably moved away from that kind of, even that thought that they would need GCC to compile Clang.
Well, it's not just GCC, it's how many other prerequisite packages do they need to build it. I mean, Clang itself, I downloaded something like 7 packages. I don't necessarily know what they all are, but they keep, kind of like X11, they're breaking it down into a small number of packages, but I don't know what order those packages need to go in. I tried to build, I extracted CFE and CD'd into it first because I thought I build Clang before I build LLVM. I typed make help and it said .. make common not found.
Mm-hmm.
It's like, okay, I need to extract this into something.
Yeah.
Is there, I looked at the LLCC
Yeah.
multiple times.
Yeah.
And unfortunately, the guy who did that downloaded a bunch of source packages, extracted all their source code, and checked the entire blob into Subversion,
Mm-hmm.
which was the point at which I stopped trying to make that work.
Yeah.
Because that is no.
Yes. So I think if you look into OpenEmbedded version, the dependencies are mentioned in there, but it's basically expecting. So how LLVM does is there is a projects directory. So you can basically include Clang, anything you want to build along into projects / whatever the project is, like C++, CXX, ABI, and all those. You can put all those projects together into a single tree. And then you can build it, and the CMakery of it will find it out, all the components that you have included in your source tree. So it shouldn't require, if you're building on like Debian or Ubuntu, it shouldn't need anything additionally what your default install is. That's what I have seen. But however, in OpenEmbedded, what we do is we build the dependencies it has beforehand ourselves. So we don't depend upon what's your build system is. So you can build on Arch, Ubuntu, any of those. So that is what we do is, I don't remember on top of my head, but all the dependencies are captured in our case. And it will build it all the way from like your native compiler onwards, and if native compiler needs a CMake, it even builds its own CMake, right? So all those dependencies are captured in there to build. Yeah. So any other questions? Yeah.
One of the things I noticed when trying to use Clang as a cross-compiler is if you just give it a target or whatever to use other than your native tuple and try to run it, it just tries to run the assembler like LLVM stuff in the path, and they end up not being for the right architecture and it doesn't work. And I know you can add your cross-compilers or your cross-assembler and all that. But do you know if there's a way, I heard someone told me there's a way to build venue tills such that it supports all the
Yes.
targets in
Yes.
one set of binaries. Can you do that?
Yes.
Can you use it?
Yes, you can do that. I think it's called with BFT all or something. There is a configure option.
Is it something that you tested if it works, or did you just heard about it? Because
I have used it like 3 years ago. It used to work. Usually it has issues with like those all deprecated targets, because suddenly they will start compiling those. So you will have build failures. But generally it worked fine once you fix those. I mean, those are like small issues sometimes. People didn't pay attention to the back. Yes, yes. So you can also say with BFT and then give it a list. Yeah. So you.
I generally work with one app with cross-compilers for a large set of targets for different targets I'm going to be testing muscle with.
Yes.
So it would be nice to be able to have one set of venue tills that supports them all and be able to use Clang when you test that without having to build
Yes.
one cross-tree after another.
Yes. Yes. Yeah. I think that's a good idea. Essentially, when we do the SDKs, for example, right, it will make sense to have that one kind of binary rules in there, and then you can target anything. You're not kind of like bound by a particular binary rules to have yet another SDK for a different architecture. Yeah.
I downloaded the binary tarball that they had on the Clang website for Debian, Clang plus LLVM dash blah blah blah, for my version of Ubuntu, and it extracted into a directory with a bunch of lib and such paths under that. I'm not sure how to install that on my host. Will it run from that directory and figure out where it is and do the include paths right, or do I have to copy all of that somewhere as root?
No, I think generally what you do is you should install it from the particular package feed of that distribution. So if you are on Debian, if you do a apt-get install Clang, it would bring in everything that you need.
I'm not sure that would give me 380, and they did give me a dev file. They gave me a tarball.
Yes, they won't give you they will give you a latest whatever they have, of course. They will give the whatever release you have installed, right? If you're on Ubuntu 14.04, then you may not get 380, right? For that.
They have a tarball on their website that says it's for Ubuntu 14.04.
Okay.
But when I extracted into the subdirectory, I don't know how to install it onto the host system, and I'm reluctant to cp-a over my host system.
You don't need to. You don't need to. I think it's yeah. So you can put it anywhere in OPT or wherever you want to put it.
I think you can put symlinks to it like in the local banner.
Yeah. Yes.
I'm not worried about adding it to my path. I'm just worried about it will find its headers and its. Okay, I can.
Yes. It has a sysroot option that you can use. Yeah.
Cool. That's what I was asking. It knows where it's run from.
Yes. So two things you can give it: the sysroot, and then where it knows where it is running from. So there are two variables it can then refer to. There are two kind of headers it uses: the system header and its own compiler headers. So the compiler headers it uses itself as a reference point. For sysroot, if you don't specify it, it will use a whatever pre-built sysroot it has, or you can specify sysroot if it is different than what the pre-built is. Cool. All right. So if there are no more questions, thank you everyone. And I'm hoping that you all will enjoy using Clang, and hopefully next time when you come around, there will be much more activity around Clang. Thank you.